Landscape architects design ways to divert and collect rainwater to prevent damage and replenish the aquifer. An aquifer is a below-ground natural reservoir of water that we use for drinking, cooking, bathing, and irrigation. The animation will demonstrate how rainwater is managed on a university campus plaza. The plaza surfaces are composed of standard materials. Concrete defines the walks and steps, and sod and lawn make up the open space. The building's roof, which also collects and discharges water, is a plain solid surface. Storm sewer and drains are ready to catch and pipe water away from the site and prevent flooding. During heavy rainfall, these materials, like concrete and sod, can only absorb so much water. The excess rainwater on the surface is funneled into the storm sewers. The building's roof diverts most of its water down pipes into storm drains as well. All this excess water, called runoff, can overtax and cause the storm drains to back up. This causes water to collect in ever-expanding pools. Too much runoff due to heavy rains can cause damage and sometimes catastrophic floods. It also results in more polluted, untreated water entering the aquifer. There are more effective means to manage stormwater using sustainable systems and materials that prevent flooding and replenish the aquifer. The first system is a green roof placed on top of a building. The green roof is layered with drainage materials, compost or planting soils, and vegetation. The green roof can absorb some of the rainfall, reducing the amount of water flowing into the storm drains. Another system involves porous pavement. Concrete surfaces are replaced with individual concrete bricks called pavers. Each paver is interlocked with its neighbor and separated by permeable material. The permeable material is composed of small crushed rocks, also called aggregates. Zooming into the cross-section, we see the permeable aggregates between and below the pavers. The aggregate-filled space acts as a sponge, absorbing water downward, diverting a good amount of runoff from the storm drains. The diverted water will eventually make its way into the aquifer below ground. The third system is called bioretention and is also known as a rain garden. A rain garden is a swale or channel that absorbs, holds, and slowly releases excess water. A rain garden section is composed of compacted soils defining the depth, width, and slope of the swale, sand and drainage materials, plant soils, and vegetation native to the region. Rain gardens are not only aesthetically pleasing, they also restore wildlife habitat. Now when it rains, water does not collect into large pools. Instead, our three systems absorb and redirect the excess runoff. The green roof prevents a lot of water from entering the storm system or hitting the ground. The porous concrete pavers absorb some of the rainwater and direct it downward into the aquifer. And the rain garden accumulates the remainder of the rainwater, preventing flooding and damage. As part of its function, the rain garden slowly releases rainwater into the aquifer over a 24-hour period. Just as important, the vegetation acts as a natural water purifier, absorbing pollutants and toxins from the water. Water is in high demand and shortages are common. These three systems are able to capture and treat more water than typical stormwater mechanisms. The systems are effective, easy to implement, and contribute to a more sustainable water management practice.